Hello? Yeah. It's just about 4 o'clock, so we'll get started. Once again, thank you for being here. I know this is the last session of the day, and you're all tired. There's a lot of information been, forced in. So hopefully this is a session where we are light on technical details, but we're more on process and how do we do things. So let me get started. This topic is evolving to operate at scale. So it's basically evolving a NoSQL store to operate at scale. Obviously, we're going to talk about Couchbase. But what I'm going to do here in this presentation is to present you with a mind map. And a mind map, as we'll see later, is a way to organize our thoughts into specific items so that it's easy for us to think about what needs to be done. So to set the agenda, we'll talk about what our mind map is, and I'll provide an overview from my perspective of the various challenges and the various vectors that we had to deal with when we talked about operationalizing NoSQL, specifically Couchbase, but other NoSQLs as well. We'll get into the details, and we'll do a Q&A at the end. If there is a question that is very specific to the slide, and you have a thought which you want to capture at that point of time, you can still ask that question, and I will repeat the question. But I've been asked to hold questions to the end if possible. Okay? So a little bit about myself. I'm currently a senior database architect and data architect at PayPal. PayPal is a very visible internet property. We enable payments. The amount of transaction processing volumes that we push through is amazing. It's in the billions of dollars per year. And I have been working with PayPal for about 5 years now. And most of my working life has always been with Oracle databases on the Unix platform. I've been doing that for about 28 years. It's a very, very long time. So, but I've switched to using various NoSQL technologies in the past 3.5 years. And Couchbase was the first NoSQL that I started to use. I've also worked on many sharded applications, both in the Oracle space and in the non-Oracle space, essentially using sharding as a way to scale. I have a passion to write and speak and transfer whatever knowledge that I can. So I'm also an author. As you can see, there are a number of Oracle books out there, which I had a direct hand in. But I also love to mentor speakers and authors. So if there's something that interests you and you're interested in Oracle and want to talk about that, come see me at the end. We'll talk about how to get your name in print. Okay. And I also I'm an Oracle ace for all the contributions to the community. And I participate in the Oracle users group. We run a journal called the Select Journal. So by audience, from the audience survey, I just wanted to get a quick feel of how things are in the room. How many of you using Couchbase in production? Okay, about 4 or 5 hands. How many of you using other NoSQL in production? Okay, again, about 3 or 4. And this is perfect because how many of you are considering Couchbase or other NoSQLs for operationalizing? Okay, thank you. And how many of you are in the process of either you are already in the cloud, using production workloads in the cloud, or wanting to move to the cloud? Okay, a fair number. So there's a spread of different kinds of audience in the room using Couchbase or wanting to get into Couchbase, wanting to get into NoSQL, or using the cloud. So we'll talk about all this because this presentation is about how do you get there, and when you get there, what are the things that you need to do, right? So before we move on, a little bit about the Couchbase landscape at PayPal. PayPal uses a polyglot of database technologies. Primarily, we are an Oracle shop. A lot of workload, critical workloads run in the Oracle databases. But we are also introducing NoSQL into we have already been working with NoSQL in PayPal for a while. And these workloads, some of them are critical, some of them are customer-facing. And obviously, we're using them to provide both scale-out as well as high availability and performance, right? So we have a number of items there. We have Couchbase, of course. As I said, we've been using Couchbase for about three plus years. Cassandra is in the mix. Aerospike is in the mix. MongoDB is in the mix. We have our own homegrown key value pair cache in the mix as well. So we deal with a lot of technologies, right? So how do we use Couchbase in PayPal? We are one of the earliest NoSQL. Couchbase was one of the earliest NoSQLs that we adopted way back in 2013, somewhere around April. Some of the people who helped us to do that are here still, Couchbase. We have Deepthi and a few others who helped us get there. And we primarily use this for low latency caching. That is a big workload, and it still continues to be one of our biggest types of workloads that we use for caching. So we also use this for a cookie store. We use this for temporary tokens, authorization tokens, identity tokens, and so on, because it's very easy for us to mint that and use that. Mostly, our Couchbase clusters are at 4.1.1 or 4.1.2, and we are planning to move to 4.5 in the next year. So we right now have about 10 large Couchbase cluster families and about 250 plus servers in these pools. Most of these servers are bare metal. We'll talk about bare metal versus virtualization versus VMs versus containerization later on. But this is where we are. So PayPal has been in talking about Couchbase at Couchbase Connect. So there's a number of Connect presentations. And I provided the links in here in this PowerPoint. Our database team is still a single team, right? So we have to deal with the plethora of database technologies. We have organized ourselves in engineering, architecture, delivery, and support, and we sort of run a virtual NoSQL team within this, concentrating on NoSQLs. We run this across multiple geographies, and we support polyglot technologies. So it's very challenging for us when we need to introduce a new technology and run that at scale and with a very, very large user base. So essentially, this talk is how we got there and what we did to get there, right? So let's look at the challenges that we faced at scale. So we in PayPal are always pushing the limits, and I'm sure a lot of other internet properties are also pushing the limits. But as database infrastructure architects, these are some of the issues that we face. Connections, and I was looking through all the other presentations, and nobody talked about connections. But connection scaling is a huge problem, right? So today, if you need to connect to a Couchbase cluster and you have the smart clients, all the smart clients need to make connections to every node in the cluster. And that is how it is, right? So the vBuckets are sharded across all nodes in the cluster, so you need to make all connections. So imagine the number of connections that we need to scale to when we have a very, very large service. We have some of our biggest pools are in the thousands of clients, right? So connections, definitely there's an upper limit on each box, and we need to be cognizant of that and use that. Memory is another problem. Interconnect is another problem on the networking and so on. CPU. In the Oracle world, if you want to change the structure of the Oracle database with the DDL to add a column, that's a very, very bad event that can happen to an Oracle database because it needs to invalidate all the SQLs and reparse everything, and there's a lot of issues that happen. And we have a lot of other problems that were specific to the Oracle world, and we were kind of stuck to saying, what do we do here, right? So we came up with a number of solutions on our own. Readout replication using Active Data Guard Oracle, microservices by sort of creating specific services dealing with the smaller amount of data so that we can isolate data by domain, custom caching at different layers with different technologies. But we are slowly reaching the limits of what we could do there. So we also wanted to go to the active-active situation, and then the NoSQL platforms gives us an ability to do that. So that is where we got into NoSQL, right? So let me make a little bit of shift and talk about this mind map. So a mind map is a hierarchical diagram that is used to visually organize information, right? It shows the relationships among the pieces, and you can create specific branches and leaves and go to any number of depths by exploring these individual points, right? So the major ideas are connected directly to the central concept, and you can organize them around specific subjects, right? So we have 5 subjects in there, and we're going to get into the details of each of this. But if you look at the mind map, the whole view looks like this, right? So I exploded all the leaves in this tree and created all the different vectors on which I need to think about or act on when I run a production scale, enterprise level NoSQL technology. So these are organized around 5 themes. What are the drivers? Who's driving this change? What is driving this change, right? How do you get to a proof of concept? What do you do next to understand whether you want to go down a new path? Is that path viable? What is it? What are the challenges that you might want to look there? That's the proof of concept. It's basically look before you leap, right? So once you get down that path, what are the pre-production steps that you need to be prepared for? So getting set before you start. Sometimes you do not have the time. Sometimes you're not thinking about this. So this might happen. This might not happen. But if you're going to get into the NoSQL world, and in Couchbase in specific, I've sort of tried to list a few things that you might want to think about. Point number 4 is probably the largest in this, and that is because running a production operation in Couchbase or in other NoSQLs is complex. A lot of things that you need to think about. How do you organize people? How do you organize the process? What are the processes that you need to have? What is the kind of alerting, monitoring, capacity framework that you need to have? We'll look into all of that. And the 5th point is tackling the known unknowns. So today is the presidential elections, and I'm reminded of a past, not a president, but a political figure who talked about known unknowns and unknown unknowns, right? I don't know if you remember that. But we'll talk about some known unknowns and things which fail, and that is that you might expect to deal with in the future, right? So the first 3 points is before, and the second set of points is after, right? So what do you do? Again, this is based on my journey, and mine specific to PayPal. So it could be different for yours. There are different paths that you could take, and it could change, right? So this is not something that you take and implement straight away without any, it's not rigid. It's flexible. But Couchbase is easy to install and use. Obviously, it gets you to start very easily. But introducing and operationalizing a new technology in a large organization and a dynamic organization is very challenging. And organizing yourself around this thought process of what to do in production can probably help you get better at doing it. So before we go down there, let's look at the decisions. And quite a number of speakers before me talked about how do you make this change from the RDBMS to the NoSQL, right? So I created a 4x4 matrix which can sort of help you decide, and it's this. So I talked about the challenges in the RDBMS world and the advantages in the RDBMS world, and the challenges in the NoSQL world and the advantages in the NoSQL. So if you look at this, I list 4 points here. Acid overheads in the Oracle space basically are a scalability inhibitor. because you need to be consistent in the database sort of makes sure that it's a shared everything system. It's not a shared nothing system, right? NoSQL, on the other hand, is a shared nothing system. You can operate individual nodes by themselves. They all need to be stitched together, but they can pretty much operate independently. The second point is that Oracle does not come with native sharding, so scale out is almost never there. You can do only scale up, right? So that comes with a cost, and that has an upper limit. And there is also a need for schema before write. We talked about this, and sort of Ravi and Perry sort of demonstrated this in the demo. They were able to change all of the structure of the data very quickly. Doing that in the Oracle space has some challenges, right? So you need to have a schema before you write to the schema. And you usually have a higher base cost because the scale-up, it's a scale-up model. You need to invest a lot right up front before you can start doing things. But there are advantages to an RDBMS. ACID is maybe essential in certain cases. Transactionality, strict transactionality is essential in certain cases. Complex data model support is available in the RDBMS. You have a system like the Oracle Enterprise Resource Planning System. Anybody using Oracle ERP will tell you that there are thousands of tables, right? They're all connected in a specific way. There are multiple keys. Trying to do that in the NoSQL world will be very, very difficult. And maintaining transactionality and consistency is going to be difficult, right? Obviously, as I said, Oracle has been around 30 plus years. So it's a mature technology and an ecosystem. There are a lot of tools around that. There are things around that. Is widely available, and skills can be easily obtained. But on the other hand, NoSQL is very, very highly scalable. It is very quickly scalable. Those are 2 points that I think are critical, right? Ravi talked about how Pokemon Go was able to scale up very quickly and respond to events. So if you wanted to do that in an Oracle system, it's very, very difficult. It's probably a huge project with a number of people and hardware additions and so on and so forth. And obviously, because you're operating out of memory, Couchbase is low latency, very scalable key value pair read write. And I said it's a flexible data model. So the key point here is that it's easy to start with the initial data model, but it may be difficult to evolve that later on, right? So the addition of new features like Nickel and so on will help you enable you to do that. But prior to Nickel and prior to GSI and indexes, it was a little difficult to add in a new access pattern to NoSQL. But what are the challenges of NoSQL? NoSQL is limited ACID, limited transactions, right? So the most NoSQLs will be, and Couchbase as well. When I say NoSQL, I'm specifically talking about Couchbase here. NoSQL is transactional at the element level, right? So you can read and write a document, and that is transaction within that one document. But the second point is something that surprises many people. So CAP theorem is real, right? You can only pick consistency or availability in a network partitioned environment, and NoSQL is a network partitioned environment. So you can make a choice of either of these two. And we talk about eventual consistency, which is, again, a pattern and a problem in distributed systems. If you come from a relational world where you talked about a single source of truth and a single database, now you're facing active systems, this thing comes into play. And you need to understand how to deal with eventual consistency. Skill sets are being, the technology is still evolving. As you can see, Couchbase has rapidly evolved, but it's still fragmented. There are multiple NoSQLs. Which one make the choice? Hopefully, you'll make a choice in Couchbase. It's easy to use, but there are some others as well, right? Skill sets are still a problem. Skill sets are not available. You can get people who can operate Couchbase, but to be able to design a Couchbase system end-to-end is difficult, right? So you need specialized people from, hopefully you'll consult with Couchbase solutions architects to do that, and we'll talk about that as well, right? So let's switch to the mind map. So I broke out the big piece and took screen snapshots of specific parts of the mind map, right? So drivers. So all organizations are perpetually challenged on things like cost and so on and so forth. But there is also a new opportunity out there, right? So today we have two major things which are come into force compared to maybe even 10 years or 15 years ago. Right? So today we have the cloud, which means that you can get hardware compute very easily in a very, very scalable model in multi-data center. So the programming model has also sort of changed to a DevOps model where developers are also the people who operate your system, and the operators are understanding of developers, right? So things like continuous integration, continuous development come into play. And you saw an example in Ravi's demo where some code was changed and it immediately appeared in production. So no longer you have this release cycle and all these other new things, right? So this new way of working requires that you have a database which does not have the same impedance that you would have with an Oracle system. In the Oracle system, if you needed to change a structure, then you file a ticket and go talk to the DBAs, and the DBAs will schedule a change. These are things which are enabled and accessible in Couchbase and NoSQL very easily and quickly. But the reality is that we still need to operate the old and the new. And you're asked to operate the old and the new with the same number of people in the room, right? Or the same number of people in your organization. And this is the challenge. And how do you ensure that you are keeping up with the old technology, but also introducing the new and managing that? This is a challenge that we went through, and hopefully I can provide some information and some insight into how we did that, right? So look before you leap, conducting a POC. A proof of concept is quite essential when you're talking about introducing a new technology. And right before this speech, we talked about how United sort of wanted to go into the new world and created something and took a system and introduced that and slowly sort of roll that out to multiple people, right? So you can have the POC in so many different ways. This can be a production POC. This can be a throwaway POC, right? So when you want to conduct a POC, you have the ability to do two things. One, choose the right use case. The use case should be simple to deploy and simple to develop and deploy, and it should be sufficiently visible and important to the organization. So when you do that, upper management says, hey, this used to be a problem in the old environment, and here is this new technology which has come in and helped me to do it very quickly. That's a pure winner, right? So you need to get management behind you, and the way to do that can be a POC. Sometimes you might have the time, sometimes you might not have the time. So you sort of got to be prepared for both, right? So when you conduct a POC, one of the things that I would like to, sort of warn you about is look for learnings, not for hard numbers, right? Don't use the POC as something that says, I improved from A to B, the old system to the new system, 5x times, right? The moment you put in a number there, the expectation is that every system that you're going to replace from the old to the new will have the same kind of cost reduction or performance improvement. Typically not true, right? What you should want to get out of the POC is learnings. How to use this, how to operate this, what are the challenges, right? So concentrate on that. It's not that you don't need to provide numbers in the POC, but it's important to get the learnings right. So before you begin, you have the opportunity in the current situation to go to the cloud. It basically means that you don't need to do any setup. You already have a number of well-known cloud providers already available, and specifically, a number of them provide managed services in the cloud. So Couchbase is working with all these 3 vendors to sort of provide that, right? So you can also do a pay-as-you-go, where you can pay as you increase and scale out. You don't need to provide all up front, right? And one of the most important things is that if you are a single data center-based system and going to the cloud, you can immediately go into a multi-region, multi-availability, right? So this can enable new availability patterns for you. But do keep in mind that when you go into the cloud, applications will need refactoring for cloud-based applications. So some of your applications are sitting in your data center. Some of the applications are sitting in the cloud. How do you keep both in sync? That's been always a challenge when going to the cloud. So what does Couchbase do? Couchbase to the rescue. It's easy to use, very simple to operate. Scale out is very simple. Single node failure is it's literally nothing, right? And you can upgrade very easily and simply. You won't even notice because you can do one node at a time, right? In terms of support, there's mature enterprise support with Couchbase. Obviously, it helps if you can interact with Couchbase support and get your designs vetted and so on. There's a large growing user community, as we have seen. The number of people attending Couchbase Connect has been growing. There are a lot of meetups as well, right? So deployment, right out of the box, you can go multi-data center. So when you go to the on-prem side, you have to make some hard and soft choices. We chose to use hard bare metals. We still want to go into the containerized world. We are experimenting with Docker, not yet on NoSQL and not of other platforms. But you have a choice when you go to the on-prem. So what is going to switch again, thought process, talk about a 3-legged stool. So running IT is like a 3-legged stool, right? All these 3 legs need to be at the same level. If not, it's going to lean on one side. People. People is a main important one of the legs in this, and it's very important. You need to recruit the right people. You need to retrain the right people. You've got to organize, lead them, manage them, and so on. But don't forget about process. So as new technologies come in, your process is going to change. The way you used to work in the old ways is gone. You need to do something differently. You will also find that the roles and responsibilities kind of shift in the NoSQL world. And the technology. Making the right choice is important, not only for your NoSQL, and hopefully it's Couchbase, but also the outer edges of this, right? So things like, do you want to use Kafka? Do you want to use like Elk Stack to get the logs from the system, visualize that, and present them in a different way? There are a lot of new things open up when you get into the open source world. Training and learning, right? So Couchbase is going to give you a lot of formal training available, but there's a lot of informal training as well in learning from others' experience through meetups, through conferences, and so on. There's a lot of, I think about 300 or 400 Couchbase blog entries. They are a valuable resource it's sort of a brain dump of all the expertise that is available with Couchbase's essays, right? So there's also a roadmap getting started, and I'm not going to go into this because all this is available in the slides, which you can get at the end. But let me switch to people, right? So people and process are very important. These are often neglected. People are people, human beings, right? So they have their own emotions and their own problems and so on. So you need to make sure that you are training them before you put them on the spot. That's critical, right? But training does not stop with going to a session or a class. It's continual, right? So you need to keep learning again and again, and that learning never stops. You need to have people who are willing to learn if you're going to go into this new world. Another thing that you need to do is to develop standards around both development, design, data modeling, frameworks, logging. There's so many other aspects that you need to take care when you talk about this, right? So let's move on quickly to how do you run a production environment. Again, I sort of have a lot of information in these slides, but some of the things that I need to point out is that monitoring and alerting needs to be solid from day one. This is an absolute must. You need to know what are the things that you want to monitor in a Couchbase cluster. And let me tell you one thing. Monitoring disk space is so important. And when you talk about Couchbase says that, hey, you leave adequate space for compaction overhead, replication overhead, and so on, that's critical. Once you go over a tipping point, you will never be able to recover that cluster. Right? So if you add, let's say you're out of space in a cluster, you want to add nodes to the cluster, right? You won't have enough space for the vbucket files to be split and ported over to the other side. You'll be out of capacity. So before you reach that level, you need to be able to catch that and respond to that early on, right? The other one is error and logging information, both on the server side and on the client side. This is critical for you to be able to troubleshoot performance issues, typically on the client side. So let me give you an example of the Java garbage collection that goes on the client side. If you're not careful, your latencies will look very bad, and it's not a server-side problem. Couchbase is going to tell you, server-side, everything is OK, 1 millisecond or less. But on the client side, you'll see something different. And you need to be able to troubleshoot this. So one other thing that I want to talk about, capacity is critical to measure and report. And Couchbase console provides a lot of information. There are some sessions in the morning talking about how do you do capacity planning for Couchbase. So the second part of this is security, right? If Couchbase needs, your data stores need to be secure from the start. These data stores are gold mine for hacking. So you need to make sure that these are well protected. And if you don't secure it from the start, you'll never get it right. Automation is key if you want to operate a production environment, right? So there are multiple ways of automating this for installation, for monitoring, for setting up these things, and so on. But also, it's important for you to establish standard operating procedures for responding to events and problems, right? So whenever you create these standard operating procedures, be open to changes to those procedures as well. As things evolve and change, and there are new types of failures, you need to go back and change the standard operating procedures. Let me talk about data management governance for a little bit. So the data model, in a key value pair system, the data model is simple, right? But as you evolve and as the data model patterns change over time, you need to go back and reevaluate what you did and how you did. What is the data model? Does that need to be changed? Do the keys need to be changed? Do the type of data that I'm storing and evolving need to change? How do I change when my data model evolves and I have old data sitting in there with a different format? These are things that you need to think about. So the next one is about the vendor relationship, right? There are a number of other things that I talk about here, but vendor and technology management is critical. Couchbase offers both the community version, which is not supported by Couchbase except for, it's supported by the community. But there's also the enterprise version. Couchbase has a lot of expertise in this area, and they can come in, they validate your infrastructure, they can validate your plans, your design. It's essential that you use them to make your project successful, right? But at the same time, don't forget the community participation. At some point of time, I was on the other side listening to other experts in Couchbase talk to me about how to operate Couchbase. As I do that, I need to make sure that the next generation, which is people in this audience, are able to come back and do the same kind of talk and share their experiences, right? So this is something that we cannot do on our own. This is not something that Couchbase can do on its own. It needs participation from everybody. So on the operationalizing Couchbase, there are alerting and monitoring, out-of-box alerting, and there's an admin console. There are links in there. But you can also build in additional monitoring frameworks. There are some Nagios plugins that you can use. But the one thing that you need to also understand is that if you're already in an existing organization which already has an alerting framework or an alerting mechanism, you need Couchbase to integrate to that, right? So I talk about that as the single pane of glass. So most organizations want a single pane of glass. So you cannot push a Couchbase console in there and ask them to look at this also, right? So you need to be able to feed into that single pane of glass, and an Nagios plugin can be useful there. Capacity management. Log all the stats coming out of Couchbase periodically, and review it periodically, and readjust periodically, right? We talked about security, build it in from the start. Production operations is a virtual loop of monitoring, responding, fixing alerts, and enhancing your standard operating procedures. And of course, involve Couchbase, for which, of course, you'll require a support contract, right? So before I wind up, let me talk very quickly about the known unknowns. Complex things and complex systems fail in complex ways, right? So you will find that as you introduce this new technology, it works great. What happens is that it can sometimes become the victim of its own success, right? Let's talk about how Pokemon evolved very rapidly, and they were failing in the first few days because they were not able to take in that load. They were able to respond, but it basically meant that they were alerting on the right parameters, and they had a plan to fix those by adding capacity, right? So when you enter into something new, you will face new unknown things. And this is where participating in the community, participating in these events will help you understand the things that you need to look for when you go into this new area, right? The second thing that you'll also find is that in traditional organizations which are built around operational silos and development silos and project management silos, that's not going to work, right? So you will need to be in a DevOps world where one team, a virtual team, sort of works on these aspects, and they have that kind of knowledge, that in-depth knowledge which cuts across multiple layers, across verticals. But you will also find that if you do not have internal learnings and meetings and information sharing, that those teams by themselves will become siloed. They'll become the cool kids in the block. They know all the new technologies, and the rest will be left behind. So you need to make sure that you put in processes in place to disseminate this technology to others as well within the organization, right? So I know I put up a lot of information, but you can always go back and read this. Couchbase, I just want to wrap up by saying that Couchbase is easy, but introducing a new technology, a new NoSQL can be challenging, right? It requires a new way of thinking, new way of working. Hopefully, this mind map will help you sort of organize your thoughts around how to attack this problem. So forewarned is forearmed, and hopefully this gave you insight into what can be out there. So connect with me on LinkedIn. I have a number of other presentations as well in the Oracle world, in the NoSQL world, and I'm happy to share and happy to answer your questions. Thank you. And we were right on time, 39 minutes and 27 seconds. Any questions? I think we have 10 minutes. Yes, sir. Just wait for the...
You had indicated that CDC for ETL is difficult. The change detection. So is there anything specific you can talk about?
Yes. So talking about, are you talking about change detection in a system where Sorry? Yes, ETL, yes. So look at the Oracle world, right? So in the Oracle world, Oracle produces the redo stream, which is its change. And there are products like Golden Gate which can listen to that change vector and distribute it in a format which is consumable somewhere else, right? So you have Golden Gate adapter for Kafka and so on and so forth. When you come to the NoSQL world, that all changes with technology, right? So in the, and it's very technology specific. So Couchbase specifically provides something called, previously it provided the TAP protocol. Now it provides, from 3.0, it provides the DCP protocol. So DCP protocol says that whenever I have a key which is mutating, I'll put that in the DCP stream. And DCP stream is the one that actually sends this data to the other nodes and also XDCR, right? So PayPal created a Couchbase adapter for Kafka. And this was not available. We developed this. We released it in the open source. So we were lucky in the case of Couchbase to be able to detect, have a mechanism to provide chain data capture, and thereby use this as a way to ETL out data that is coming into Couchbase, right? Typically, you don't need to ETL out if Kafka, if your Couchbase layer is a caching layer, because it's not the source of truth, right? But when you want to evolve this Couchbase as a source of truth, you need to think about some of the other layers that are already existing and mature in the RDBMS space, like ETL. In the case of Couchbase, you can use the DCP Kafka adapter to get the data out, but it also means that you need to use Kafka on the other end to use that as a messaging system to move this data from here into wherever you need it to take it to. Does that answer your question?
Yeah, part of it, but that's fine.
Is there something specific? Then maybe we can talk about this right after. Any other questions? Yes, sir.
Could you describe a little bit about what kind of cluster management tool you are using on bare metal, container, VM, or a combination of some of them? And also, could you describe a little bit about what kind of storage architecture you have?
Okay.
Yeah.
Sure. So let me start with the second question, right? Remember, NoSQL is a distributed shared nothing system, right? Although Couchbase says that you can have a storage area network behind your cluster, that is not the recommended route. Because if your storage area network fails, then all the nodes in your cluster are gone, right? So typically, you will see that you have NoSQLs with their own internal disks and local to that system, right? So if the disk failed, or the node failed, or the CPU failed, the memory failed, that node is down, and that portion of the workload is not available. When that happens, Couchbase automatically detects that. It does the auto failover, right? It elevates all the other replica vBuckets, and then you're gone, right? So you have a temporary glitch, and everything is fine. Coming back to what kind of nodes these are, let me give you an anti-pattern. Somebody talked about, you had one hypervisor, and you built 8 VMs in that hypervisor, and you created a cluster of 8 nodes in that hypervisor. That is a totally anti-pattern, right? So if your hypervisor goes down, all your 8 nodes are down. And unless you have XDCR out into another cluster, and you have the ability in your applications to detect this failure and switch automatically to the other side, your total Couchbase cluster is down, right? So we experimented with multiple technologies, having virtualization machines and so on and so forth, and settled on bare metals. But it's not a perfect story. The challenge that we have is If I want to have a workload A, I create a cluster for workload A. I want to have another workload, workload B. Should I create another cluster, or can I share this cluster if there's enough capacity in there? You do that by creating multiple buckets. And Couchbase allows you to create multiple buckets, but there is an upper limit on that bucket. Typically, Couchbase says that, hey, don't create more than 4, because the number of threads that need to access those V buckets increases with every bucket that you create, right? There are some optimizations in 3 to sort of take care of the number of threads. But even with that, there is an upper limit of 10 buckets per cluster. The other problem is that when you create this multi-tenancy at the bucket level in a single cluster, when you want to upgrade that cluster, all 10 workloads need to upgrade at the same time, right? So what is the better solution in this case? What we are looking at is how do I create Docker containers in this virtualized environments to be able to create a slice out of that cluster and isolate the workload to that particular cluster and make it look as if it is a single node or a set of 8 nodes in that cluster. This is a pattern that we are evolving. Obviously, we are not there yet. Today, we run bare metals with multi-tenancy in those bare metals.
So for each container, what is the typical size
Okay.
volume to attach to the container?
Sure. So the question is, what is the size of each of those containers? The size of the container is determined by your sizing of the node, right? Typically, Couchbase is memory intensive, and the capacity for Couchbase is driven by memory, amount of RAM available. So if you have a 1 gigabyte, or let's say some of our clusters are in the range of about, they hold about 2 billion keys, right? And we have a replica of 1. It means that the whole cluster typically has around 4 billion keys. You can do that on a 12-node bare metal with 384 gigabytes per node. But when you talk about containerization, you basically need to make sure that the workload that you have is spread around on that particular cluster. If it's an 8-node cluster or something like that, you allocate enough nodes into that cluster with, let us say, 64 gigabytes of memory or 128 gigabytes of memory. It essentially is driven by the amount of RAM that you require, not by the number of nodes or the queues for each of those containers.
Thank you.
You're welcome. Yes, sir.
What's the cache resident percentage you have in your system?
Yeah. So so this is what we want to attempt, right? So initially, we were looking for 100% active resident ratio. Obviously, that is not possible. What you need to look for, we have systems which can go up to 20% active resident ratio, all the way up to 70, 80% active resident ratio. It all depends on what type of data it is. So if I take a store, which is a cache, very large cache, I know that for that cache, maybe 10 or 20% of the items in that cache will be hot at any point of time, right? There are other workloads which are temporary session stores which need to mint a token, and then the token expires. The active resident ratio in that case that I need to mint and have a short TTL is very high. So the active resident ratio of a temporary session store will be in the 70s to 80s. The active resident ratio for a long-lived cache will be in the 20 to 30, right? Yeah, so the question is, do you have compaction running at a scheduled time or during a specific time? We try to sort of limit that based on what kind of timeouts we have. If you don't throttle the compaction down to a particular time, it could start at any time, right? It could be in the middle of the day or in the morning where traffic is higher. So we want to definitely control that. We run that during our low periods. Obviously, our week-on-week and year-on-year shows an up and down sine curve pattern. we pick the right time so that we run the compaction within that period. You also need to remember is that that compaction is not fixed, right? And I talked about this feedback loop that you need to have and alerting and right monitoring in place to be able to go back and change your parameters based on what's happening out in production, right? So we fix a particular period, but we are extensible and we can expand that period if required. One of the things that we have seen is that if compaction does become a problem, it basically means that we have got our data access pattern wrong, something changed in the application, the way they are updating or inserting, and we can add capacity to the system to sort of bring that down, right? So the moment you add more nodes into the system, it means that the number of vBuckets per node comes down, so the compaction can catch up for those limited number of vBuckets. Does that answer your question?
Yeah, so what's your normal fragmentation percentage you observe during the peak time?
So the question is, what is the normal fragmentation period? All this is driven by the application, what the application does, right? As I said, we have different workloads and different families. If there are workloads which have a short TTL but get generated very quickly, then obviously their fragmentation numbers are higher, right? We aim for about 30 to 50, but there's nothing strict about it. So rather than get fixated about what are the numbers and what is the active resident ratio and things like that, we got to sort of turn this around and say, are we meeting the SLAs? At the 99th percentile, are we able to serve gets and sets at 1 millisecond or lesser? If that SLA, that one single number is violated, then there is a capacity problem. We need to go back and check and sort of adjust, right? So rather than look at hard numbers and best practices around those numbers, let your use case and your SLA drive what you're doing. Again, that's a finding that we have, and that could be different for others, right? I think I have one more minute, so I'll take one more question.
So you own your own data center, right? So you have your own data center. I'm just curious, is this enterprise scale, is your cluster homogeneous or heterogeneous?
Okay. Yeah. I think there are two questions in whatever you asked, right? So the number one is that, yes, we own and operate our own data centers, but we also are a leading proponent of OpenStack, right? So we will always have use of other cloud vendors as a back pocket. How much of processing and what type of processing we send to cloud vendors is still negotiable and up for a discussion, right? So that is number one. I'm sorry, I forgot. Yes. So the second part of the question is, are your bare metals all the same or heterogeneous? There are two parts to this question. We want to keep all bare metals heterogeneous, right? But you will quickly land up in a problem later on. What happens is this. Some of the initial systems that we set up are like about 3 years ago. You will never get the same SKU again, right? So the new SKUs come in with faster CPUs, more memory. We need to have something that puts that in and take out the old. So if you go back in here, one of the things I talked about here is fleet management, right? So in the fleet management, you need to have an asset catalog. You need to have an asset lifecycle management. And in the lifecycle management, whatever you're asking comes into play, right? So we need to bring in the old, bring in the new, retire the old. Very, very simple and easy to do in NoSQL. You just do a swap rebalance, and you're done. The old one is out. Does that answer your question? Okay. You can see that I've had all the scars, right? Any more questions? Okay, I think we are just out of time. Thank you very much again. Thank you for staying until the end.